volume flow measuring of fresh air volume flow in a room. We may need to know the amount of fresh air persons are getting in a room. There are several methods how to do that, and we will discuss today an easy method using a tracer gas. A well-known tracer gas is helium, but it comes with a price and you need special measuring equipment. Whether exists a cheap method is to measure the carbon dioxide concentration in a room. That you only need a CO2 sensor and you need the time. And now we can discuss how that is done. Anyway, in our discussions we need to know what we are talking about. So concentration is usually known as a percentage. However, the concentration of CO2 is a very low percentage. This amount of fresh air consists of 0.4% of CO2 in the fresh air. We will say that is a very low percentage, and so that is normally expressed as 400 parts per million. Now we will show how we go from a percentage to ppm. 1% is 1 cubic meter of CO2 in 100 cubic meter of fresh air, and that's expressed as 1%. Then you go to 0.1%, 0.01%, and we can go to 0.04%. And that is 400 ppm, and that is 400 cubic meter of CO2 in a million cubic meter of fresh air. And that's the lowest sentence. After a while, people emit CO2, but after a while the CO2 concentration will become time independent. And when that happens, after a couple of hours, we call that the steady state situation. And then there is a balance. The volume flow of fresh air is constant, the production of CO2 of the people is constant, and the concentrations of the CO2 in the inlet air and the concentration in the room are all constant. And then we have a very simple formula between the two volume flows, the fresh air volume flow and the volume flow of the CO2 production, and the concentration in the end situation and the concentration of CO2 in the inlet situation. So that's an easy formula. We can use that at the end, but now we need more symbols to define. The symbol Q stands for a quantity, the V stands for volume, the production of the CO2 is also a Q with a V, and that's all in cubic meters per hour. The concentration is a small c with a 0 for the initial concentration in the room. The end situation has an E for the steady state, and the I is for the inlet air. Carbon dioxide production of a person depends on their activity level, and if we are now talking about a conference room where people are listening and they're sitting with a low activity, perhaps some writing or slight moving. If there is no activity, then their metabolic equivalent of task is 1.0 met. If we have a lot of sitting activity, then that shows 1.8 met. We will use a 1.4 met, which comes with a production of 19 liters per hour of CO2. Of course, the person which stands speaking makes a bit more carbon dioxide. After a certain amount of time, we have a slowly increasing carbon dioxide concentration, and then we need to know the time. The time is T in hours. We have the carbon dioxide concentration after that time, that's called C. Then we have C0, that is the initial concentration in the room at the starting point of the measuring. That can be a bit higher than the inlet concentration. But then we have the number of air changes. That's the number of air changes per hour. We have the volume of the room in cubic meter, and then the fresh air volume flow is N times V. Now we have quite a difficult formula for the concentration in the room. It has an exponential function E with the time T and the number of air changes N. Then we know that the fresh air volume flow is N times V, and the concentration is always in cubic meter CO2 per cubic meter of fresh air. So the concentration is always in cubic meter per cubic meter. Then we go to the concentration calculation example. We have a room, a very large room, 14 meters by 7 meters, with a room height of 3.2 meters. We don't have much people in the room. We have 19 listeners and 1 speaker. The speaker has a slightly higher carbon dioxide production. We can calculate the total carbon dioxide production. That's 19.19 plus 1.25. Then this amounts to 386 liters per hour, and then we make cubic meters per hour from it. That's 0.386. The room volume we now know, that's 331 cubic meter. We have the concentration of the inlet air, which was 400 ppm, which amounts to 0.0004 cubic meter per cubic meter. We have the initial, the C0, that's the starting value in the room of the concentration, and that gradually goes up. We now have taken the measurement, and we say, okay, we take the measurement of the concentration after 1.5 hours, and then we find 900 ppm. We have to express that in cubic meter per cubic meter. The exponential function, the E value, is 2.71. When we look at the formula, then we see that we only have one unknown, and the unknown figure is N. And now we say we can find N by using a trial and error method. And how do we do that? We make a formula with all the symbols on the left, and the right hand side then has to be 0. we have an expectation of the concentration that will be say it will be between 400 ppm and perhaps 2000 ppm or maybe higher. And if the right hand side is 100 of the expected value, then we normally are correct. You also see that when the right hand side becomes negative or is on the edge between negative and positive, then you also are near the exact value. By doing so, we find that the number of air changes amounts to 2.27, which is a bit low, but that's due to the fact that we don't have many persons in the room. Otherwise it could be should be higher. Then we say, okay, the fresh air volume flow is N times V. That amounts to 753 cubic meters per hour. And then we say we have 20 persons in the room, and then per person we have 38 cubic meter per hour fresh air, which is quite acceptable. In a theater you have a minimum of 20 cubic meters per hour. So 38 is a very good amount per person. Also the 900 ppm is also very acceptable. Figures higher than 1200 are not so good, and figures below 800 are excellent. The steady state figure we can now calculate. We have all the knowns, and then we find that after more hours the CO2 concentration in the room goes up to its maximum of 912 ppm. So this is the method, and I can say for an experienced engineer this will be known stuff, and for a beginning engineer this can be a big help in performing the measurement and to calculate the outcome. I thank you for your attention.